This is Mrs. Naslund, and today we'll be doing Unit 7, Lesson 3, Divide by Numbers Other than 5. Our learning targets for today are, I can understand real-world division situations. The second learning target is, I can practice division with 3- and 4-digit dividends. So, first thing we're going to do is review our steps of long division. First is daddy. We divide the number. Then mother, we multiply the number. Sister, we subtract the number. Brother, we bring it on down. And Rover, our pet dog, we repeat or we do the remainder. So let's go ahead and practice with some word problems. The first word problem we're going to read says, a helper in the school store suggests selling notebooks in packages of 4. How many packages of 4 can be made from 192 notebooks? All right, so the first thing I do is I like to go ahead and find my numbers. I know that there are 4 numbers. I'm going to make it a little neater so you can see it. There are 4 notebooks per package, right? 4 notebooks per package. And there are 192 notebooks that we're trying to make, all right? My question is, how many packages of 4 can be made from 192 notebooks? So I'm going to use grid paper today. Again, you can always turn your paper sideways, or you can use grid paper to practice. I'm going to go ahead and set up my division equation here. I know I'm going to be dividing 4 into 192. And again, I know that because they want to know how many packages of 4 can fit into 192 notebooks. So I go ahead and write my division problem. And then first thing I do is daddy, divide. Does 4 go into 1? Nope, it's too small. So I have to go into the bigger number. Well, I know that 4 times 4 is 16. And if I go to 4 times 5, I'm going to get to 20. So that'll be too big. So I'm going to go ahead with 4. It goes in 4 times. So now I multiply. 4 times 4 is 16. Then I go on to the next step, which is sister, which is subtract. 9 minus 6 is 3. And 1 minus 1 is 0. And then I get to go to brother, which is bring it on down. I have a number sitting here, so I get to bring it down. And then since I brought something down, I get to do the repeat. Okay, so I go back up to the top and I get to divide. 4 into 32. All right, 4 into 32 equals 8. And then I get to multiply. 4 times 8 is 32. Get to do sister, subtract. 2 minus 2 is 0, and 3 minus 3 is 0. So then I get to do remainder. And look, there is, well, first off, there was nothing to bring down. So then I get to go to remainder, which is 0. So my answer is I could put 48 packages out of the 192. 48 packages of 4. All right. Now, I'm going to read this one, and then I'm going to let you go ahead and try this one on your own. It says, another student suggested selling notebooks in packages of 6. How many packages of 6 notebooks can be made from 192 single notebooks? So the exact same thing we did here, but instead of dividing it by 4, you get to divide it by 6. So go ahead and work it out on your own, and pause the video, and we'll see how you did. All right, so go to solve this one. This time I'm looking at 6. I'm looking at 192. So how many times does 6 go into 192? I'm going to write my problem here. 6, 2, very good. 6 into 192. All right. And then I go ahead and do the first step, D, divide. 6 into 1 can't because this is a smaller number, so I have to do 6 into 19. Well, I know 6 times 2 is 12, so 6 times 3 is 18. That's really close to 19, and it's under 19, so I think that's going to work. So now I multiply. 6 times 3 is 18. Then I get to do the sister step, subtract. 19 minus 8, 9 minus 8 is 1. I go to brother, bring it on down. And then since I brought down a number from my rover, I get to repeat. So I get to go back up and divide. 6 into 12 is 2. 6 times 2, multiply, this is the mother step, is 12. And I get to move on to sister, subtract. 12 minus 12 is 0. Now I can't bring anything down because there's nothing left. So I have a remainder, which is 0. In this case, I don't have to write it. So what you should have gotten is that 192 divided by 6 is 32. So there'll be 32 packages of 6. All right, great work. I'm going to do 2 more problems here. Here we go. This one says, the store will sell packages of notebooks for $3 each. Would packages of 4 or packages of 6 be a better deal for the students? So this is kind of more of like a logic problem. So I could get 4 packages for $3, or I could get 6 packages for $3. Which one do you think is a better deal, right? Would you rather pay $3 for 4, or would you rather get 2 extra, right, for the same price? And the answer is that the 6 is a much better deal because students would be able to pay the same amount and get 6 packages instead of 4. Now, which package size would make more money for the store if they sold them in packages of 4 or packages of 6? So think about the store's perspective. Does it make more sense to sell 6 for 3 or 4 for 3? And the answer is actually the 4 is a better deal for the store because that means people might be forced to buy 2 sets in order to get that 6 that they might have needed. So in this case, putting them in packages of 4 is a better deal. So you can see that when you're doing long division word problems, sometimes you're actually going to have to solve them, and sometimes it's just looking at it logically and figuring out what the problem's asking to go ahead and solve. All right, the last thing we're going to look at today is using mental math to help you find patterns when dividing a number by a 10 or 100 or 1,000, anything that ends in a 0. So I just want to point out some of these patterns. When I look here, we've got 20 divided by 10. We know that if we do 10 into 20, or 10 times what equals 20, the answer is 2. 50, same thing. 50 divided by 10, we're going to get 5, right? Just drop it. Drop that 0 and you have your answer. But what if it's like 200? I want you to notice this. It works the same way, except you add an extra 0 on. So I think, okay, 10 into 20, I get 2, but I have that extra 0, and you know what I do with it? I add it on. So I can say it's 20. What about if it was 2,000? What do you think we'd get? If you guessed 200, you'd be right, because you just keep adding zeros for the number of extra zeros you're dividing into. Okay? Well, this one down here, this one's a little bit tricky. 10 into 110. So I think to myself, okay, well, how many 10s go into 110? And what you would get is, again, if you drop that 0, you would get there's 11. In this case, I just dropped that last 0 again, and now I would get 110. So you're just dropping that last 0 if you're dividing by 10, okay? So let's see if you can do some of these mentally. So I want you to think, how many 10s go into 40? Or 10 times what equals 40? Can I just drop that 0? And what do I get? 4. How about this one? 800 divided by 10. So again, how many 10s go into that 800? Again, the trick is just get to drop that last 0. And what's my answer? 0. Or sorry, 80. So we keep doing that and it works. How about this one here? 60 divided by 10. Again, I get to drop that last 0. And what's my answer? 60. Now when it's 10 goes into 10, how many 10s go into 10? The answer is 1, right? Because only one 10 can go into 10. Now these ones get a little bit more tricky. How many 10s go into 310? And again, this only works when they end in zeros. But again, I just get to drop 1 0. Since there's 1 0 here, I can drop 1 0 here. My answer is 31. What do you think this one would be? Go ahead and pause and figure this out. 670 divided by 10. Again, I do my trick. If I have 1 0 here, I can drop 1 0 here. So my answer is going to be 67. All right. Good, so that's a trick for when you're dividing by a 10, and you can use those tricks when you're doing by tens, by hundreds, by thousands. Just a great trick to know. So today we talked about, again, our steps of long division. We applied them to some word problems. We talked about using logic when you're trying to solve word problems. And lastly, we did some tricks for when we divide by 0 or when we divide by tens or hundreds. Thanks for listening.